So this is the first of our video tutorials on basic physics skills. Alright, so we're going to introduce you to the idea of powers of 10, something you should be familiar with from algebra. Just going to go over some of the basics because it's become important for the first few weeks and also help you out in the long run, especially with your graphing calculator use, because so often students misuse it when you're dealing with powers of 10. Okay, so it is important that you have your calculator in front of you and your reference tables, because we're going to look at them to do some of these problems before you have practice on your own. Alright, so one of the first things we're going to establish is that the universe, which is what physics is all about, trying to understand everything in it from the biggest to the smallest, has a vast range of size and mass and other quantities that we have to be able to measure and quantify. So one of the easiest first ways of quantifying, assigning a number to a size of something or how big it is, mass, how much time it takes, is to do a power of 10. Okay? So you just want to review the rules, understand that your reference tables has some prefixes in it that you have to be aware of, and know how to look up and use them appropriately. All right, so I'm going to start with scientific notation and prefixes of power of 10. So if you go to the bottom left-hand page of your reference tables, you will see a table that has prefixes from tera to pico. Okay, so let's just go through it, make sure you understand. And if you have questions, you can come into class and ask. All right, so it says find a mega symbol. So that's for mega. Mega's symbol, capital M. That's a prefix. So when you have a mega of something, okay, as the reference tables tell you, it represents 10 to the 6th, okay? And that's a million. All right, so if you write it out as a long number, 1 followed by 6 zeros, that's kind of cumbersome to write. So we can write as 10 to the 6. 1 times 10 to the 6 would be okay as well. But that's pretty basic. If we look at micro, okay, micro, most people understand, means small, but it has a specific meaning. So its symbol is a funny letter. It's a Greek letter mu. So I'll just draw it like that. And that means, if you will, the opposite of mega, 10 to the negative 6th. So if you were to write that out as a decimal, okay, it's 1 over 10 to the 6th. That would be 0.012, 3, 4, 5, and then a 1. So it's a very, very small number. So 10 to the 6th is large, 10 to the negative 6 is very small, and if we divide the two, we see that there, if you remember how to do that, is a big, big, big difference. And we'll talk about that in a second. Okay, so a problem you might have to do. All right, so let's say you're told something, a virus is 80 nanometers wide. Okay, so the base unit there is a meter. And we'll talk about metric in that in a little bit. But what's that nano there? Okay, so if you look up in your reference table, nano means that its width is 80. That's in front of the nanometers. And then if you look up nano, right there, and the symbol is an N, sorry that crossed out, that's 10 to the negative 9th. Okay, so 10 to the negative 9th is a billionth, really, really tiny, so it's 80 billionths of a meter wide. Now, when you go to type things in, you have to do calculations on your graphing calculator, there is a special button that's meant to deal with it. And it is not the 10 caret button that so many students use. So I want you to introduce you to the EE button. Okay, so the EE button is found by pressing second button and then the comma. And the comma is right above the 1, 2, 3, 4 on your calculator. So locate that right now and see above it, and I believe in yellow, at least on the TI-83, it's an EE button. EE on a graphing calculator simply means 10 to some power. And then after you put a number in, then you're telling it's 10 to the 5th, 10 to the 7th, 10 to the negative 3rd, whatever the case may be. Okay, so let's do a quick some practice. Again, using our reference tables. Let's find the ratio of a gigaton to a kiloton. So ton is amount of mass. Giga and kilo are prefixes for amounts, convenient amounts. So look up giga, all right, that's a billion, 10 to the 9th. Kilo, you should be familiar with, is 1,000, 10 to the 3. Okay, now we ask what's the ratio. Now in mathematics, you learn that ratio is often written as, let's say, 2 to 1 or 1 to 6. Okay, well that's true. In physics, that generally, when you say ratio, we have a different interpretation of that. What we really mean is we want to divide. So whenever you're asked to find a ratio, that means take two numbers and divide them and give their quotient. Don't write it as 1 to 5 or something like that like you do in math. So in this case, if we're doing a ratio of a giga to a kilo, A giga is 10 to the ninth, a kilo is 10 to the third. Divide them. We should be able to do that in our head. And that's 10 to the sixth. So a gigaton is a 10 to the sixth times bigger than a kiloton. In other words, 1,000,000 times more. All right, let's try it now for something maybe a little bit more pertinent to physics. Okay, so let's look at the ratio. Okay, that means how much bigger is one than the other, or smaller, to the distance of the sun to the earth to that of the moon to the earth. Okay, so we're sitting on Earth, the moon is a certain distance away, it's much closer than the sun is, so we want to basically ask ourselves, roughly, how much further away is the sun than the moon? Well, you're not expecting to know that off the top of your head. If you go to the front page of reference tables, you see the first table has a bunch of important numbers, and we'll see about a third of the way down, we'll see mean distance to the Earth to the moon, and mean distance to the Earth to the sun. So I'm just going to write the power of 10 here, because I'm looking for an approximation right now. Okay, so I'm going to use the symbol D for distance, and I'm looking for sun to the earth. Look on the reference tables, and I see it's about 10 to the 11th meters away. Okay, 1 followed by 11 zeros, so 100 billion meters away. On the other hand, the moon is much closer, and that's roughly 10 to the 8th meters. Okay, so 100 million. So now we're going to divide the two values using our EE button. Looks like I must have put the numbers in my bag. Let me put in the numbers, coefficients in front. So this would have been about 1.7 times 10 to the 11th. And moon is, looks like I did wrong. Look at the wrong thing. 1.5 times 10 to the 11th, and the moon is 3.8 times 10 to the 8th meters. Okay, sorry for that little error. Anyway, I suggest use your graphing calculator here, or scientific calculator, to type these in to verify that when I divide the two values, that's what ratio means. Okay, I get about right, 1.5 times 10 to the 11th divided by 3.8 times 10 to the 8th. That's approximately 390, or if I write the scientific notation, 3.9 times 10 to the second power. Okay, so there are often times you want to write things in scientific notation, and you should be able to go from 390 to scientific notation. If you're not sure, ask in class and we'll review that. All right, so the next three problems, I want you to stop the video, press pause, and try the next three on your own. Okay, it shouldn't take you more than a few minutes. You will need to use reference tables for part C, but the other ones, even maybe part A. And the answers are in the back. So once you're done, check in the back, see if you got them right. If you didn't, do it again. And if you still can't figure it out, again, ask me in class. All right. Then to finish up, I want to introduce a term that's related to powers of 10, and that's called orders of magnitude. We're going to be doing some exercises where we want to look at how many orders of magnitude is something in terms of mass or distance or time. And order of magnitude is just a fancy way of saying power of 10. Okay? So, for example, let's say I want to know how many orders of magnitude the term tera means and pico, respectively. So again, you're not expecting to know those off the top of your head. You go to your reference tables, we look up the word tera, and we see it's 10 to the 12th, and pico is 10 to the negative 12. So tera is a huge amount, trillion. Pico is a tiny amount, a trillionth. So if an order of magnitude is a power of 10, then tera is 12 orders of magnitude. As simple as that. So whenever we say there's 12 orders of magnitude, it's understood that's 10 to the 12th. Not the number 12, but a 1 followed by 12 zeros. Whereas pico is negative 12 order of magnitude. That's a little bit more awkward, but what you're basically saying it's 1 over 10, or 1 followed by 12 zeros. So it's a tiny amount when you're in negative 12 orders of magnitude. And if we want to find the ratio, which we often do, I divide 10 to the 12 by 10 to the negative 12. If you remember how to divide exponents, you really subtract them. 12 minus negative 12 is 24. So there's 24 orders of magnitude difference between those two quantities. That's huge. we'll see in nature, we're going to actually have to explore that huge range. Okay, one last example. A heart cell is roughly this funny thing that's micro, if you look it up, meter in diameter, and a heart is about 10 centimeters in diameter. So how many orders of magnitude is the heart's diameter to the cell that actually makes up a heart? And you could use that to kind of approximate how many cells make up a heart, based on dividing the overall diameter of the heart by the diameter of one cell that makes it up. Okay, so we just need to make sure we understand what the prefixes mean. So we have 1 micro. If you look it up, that's 1 times, micro means 10 to the negative 6, and we retain the meters, because that's our base unit. 10 centimeters, well, we should know what cent is, but if you don't remember, it's in your references. So it's 10, because I have this number. 10, centa means times 10 to the negative 2 meters. Okay, we want the ratio, so that means divide. So on my calculator, I do 1 times 10 to the, I'm sorry, I got that backwards. I'm going to do the heart to the cell, so I'm going to do 10 times 10 to the negative 2 meters divided by 1 times 10 to the negative 6 meters. So the meters cancel out, meaning I'm just going to get a pure number. 10 divided by 1 is equal to 10. 10 to the negative 2 divided by 10 to the negative 6. Again, you should be doing this on your graphing calculator to make sure you get the right answer. Just don't listen to what I say and copy it down. Is 10 to the negative, or excuse me, 10 to the positive 4th. So 10 times 10 to the 4th is the same as 1 times 10 to the 5th. So there's roughly, the heart itself is 100,000 times bigger in diameter, at least, than the cell. Okay, so if you have any questions, ask, and then we'll do more practice in class.